Good evening to you all. My name is Mbabaset Sapeshali, and I'm going to be talking about the different, or there are very many other machine learning techniques to use to make sure that you have an optimal model in regards to complexity. So today I'm going to talk about a few. There are five that I found out, and we do have yes. We do have, there are three types, like major types. We have the dimensionality reduction types, and then we do have shrinkage types. And under dimensionality reduction, we have feature selection techniques and feature extraction techniques. But what is dimensionality reduction? So dimensionality reduction, this refers the dimensionality is like the whole set of the data set, the whole data set. And then the dimensions are the features or the different columns that the data set has. So under feature selection techniques, these are techniques a person uses, or feature selection in general. It is selecting selection of features from a big data set that a person thinks are relevant to use in training their model. So this selection all depends on what you want to achieve, what your data set is like, and it is. So under feature selection techniques, we do have the filters method. This one is used to select a subset of the features from the data set that through filtering that you can use to train your model. And you can do this using some algorithms like correlation. You can also use the chi-square test and the ANOVA. Then we do have the wrappers method. This one evaluates the machine learning model by feeding in some features to evaluate its performance. So after this one works in a manner that after developing your model, you keep feeding in a particular feature. After feeding in the feature, of course, after developing it, you've assessed its performance, and then you have a value of that performance. Then you keep, after that, you keep feeding in one feature per time, or removing a feature. You remove or add a feature. When you remove the feature, you run the model again, yeah? After running the model, you assess its performance like that. So you continue, then you put it back, then you move another feature, then assess the performance of the model, that particular feature. So after that, that's when you realize the features that do not show a significant change in the performance of the model when it's not there. That is an irrelevant feature. So it doesn't matter whether it's there or not. So you remove it. And then a feature that shows a tremendous or a significant change in the performance of the model. That means that it's a very important feature and you cannot do without it. And then we go to the embedded methods. These are used to check the different training iterations of a machine learning model to evaluate the importance of each feature. So you can use an algorithm such as LASSO to assess that. Then we have feature extraction. This is transforming a space with many features to a space with few features. This can be achieved by using the linear discriminant analysis. So now I'm going to begin talking about the different algorithms that we can use. The other ones were more like categories. These are like the algorithms themselves that we can use to achieve an optimal model in regards to complexity. So here we have the principal component analysis. They say it is a statistical process that converts the observation of correlated features into a set of linearly uncorrelated features with assistance of orthogonal transformations. The new transform features are known as principal components. So after getting the principal components, so that's the ones that you will use in training your model. And this works by considering variance of each attribute, as a high attribute shows a good split. So the higher the variance is among features, that means, or the split, that means that you're on the right track and that feature is necessary to build training models. Otherwise, you repeat. Then we have the backward feature elimination. So the way this feature works, you've trained your model linearly, and as you can see, it's a linear regression or logistic regression algorithm, and that's where it's mostly used. So here you have like a full data set which has a number of features. So after training your model, you keep removing a feature, and every time you remove a feature, you run like you run the model to see its significance, and you train the feature. So you remove a feature, train the model on n-1. Since you removed a feature, that means the number of features reduces by 1, and you train it for n times. Like you train it for the number of times that is remaining, and we'll compute the performance of the model. Then we will check the variable that has made the smallest or no change in the performance of the model, and then we will drop that variable or feature. After that, you'll be left with the n- features. Yeah, and then you repeat the process for all the different features. And then you can drop a feature that you deem, useless. Then we have LASSO. This is a regression model, and it belongs under linear regression or shrinkage. And shrinkage is the reducing of the extreme values of a dataset towards central values. Since the model performs L regularization, and the penalty added in this case is equal to the magnitude of coefficients, so LASSO makes the regression simpler in terms of the number of features it chooses. So this one uses regularization, where a feature is reduced to 0 if it's not useful or doesn't make significant change in a model. Therefore, those that are reduced to 0 are dropped off, since they are like useless in the model. Then we do have the Bayesian model averaging. This one takes up you do develop your models with different maybe classification methods, whatever you choose to develop your model. And then you get several models. After getting several models, these models are taken, are averaged. You average them and you choose the best. It gives you like the best model to go with after averaging all of them. That's why you see here we have a set of models from M1 to MK, and after averaging them, you get the best model to choose. However, most researchers do not recommend this model, as it is very sensitive to prior choices, and also it tends to select only one model. Then we have the missing value ratio. If you find yourself that you have a data set with a feature that has a lot of missing data, then automatically that's not going to, do much change or difference in the results of your model, or when you after training your model and you're testing it. So it's not going to do much change in the results of your model, what you get. Therefore, you can drop that feature. And yeah, one thing I forgot to talk about is the threshold, where you can set a threshold level. Say, if this particular feature does not have maybe this particular number or this much data, then that means that whichever feature won't have data that amounts to that threshold that you've chosen should be dropped. And yeah, these are my references, some papers from which I got the information that I have there. And yes, thank you for listening. You learned something. This is open to comments, advice. Yes, thank you.